Hello everyone, we're gonna talk about Adaboost and Haar-like feature, but I want to explain something about Adaboost. Adaboost is the native boosting algorithm. The goal of boosting is to improve the accuracy of any given learning algorithm. First, a weak classifier with an accuracy under training set greater than a chance is created, and then new component classifiers are added to form an ensemble whose joint decision rule has arbitrarily high accuracy on their training set. And well, new this, we can explain more the algorithm. Well, first we need the weight, and then with that weight, for example, this is our first weight, and for this weight, well, we have a lot of components here. For example, the normalization constant and this one. This constant implies that, for example, if y equals ht, then c equals to e. Well, the only change here is the sign, the sign. But we need also alpha. Alpha is determined by this formula. It's really easy, really. And we have to consider that the error is less than 0.5. For example, if we convert here the error in 0.5, 1 less 0.5 is 0.5, and 0.5 and 0.5 is 1 here. And finally, if we do this algorithm, it's gonna be 0, and 0 is equals to 0, and it's a condition that alpha must be greater than 0. That's why it has to be less than 0.5. And well, if y is not the same that h, I don't know, for example, if we have this is for binary decisions. For example, if we have if it's a phase, okay, c is equals to this. If not, well, this case. And finally, we have to upload our weights with this formula. Okay, it exists a lot of variants of this kind of algorithm. For example, Logitboost. And well, Logitboost represents an application of established logistic regressions techniques to the Adaboost method. Rather than minimizing error with respect to y, weak learnings are chosen to minimize the error of the function. And finally, well, this is the equation, and the equation implies the Newton-Raphson approximation. But well, you can also check it a lot of kinds of Adaboost, like this logic boost, gentle boost, and Friedman's wording. I don't know, it exists a lot of kinds of Adaboost. But well, the pros and contras of Adaboost is I want to say that Adaboost is really fast, but the contra is that, for example, this the weak classifiers are too complex, leads to overfitting. And other contra is that Adaboost doesn't work with linear models. Okay, we made an example. This example is about we want to classify two kinds of animals. In this case, it's rabbits and ducks according to the length and weight. And that's why we create some new variables here, random variables, but with a little restriction. Yeah, this is for the rabbits and for the dogs. And then we have to well, in this case, we were gonna plot. We're gonna graph the dates here, for example, and finally, this is the training data. And then we have to use Adaboost. Well, this is a function, but this function includes the algorithm with all the operations. And then well, you can also change here the number of iterations, for example, but it's very important that the number of iterations will be great big. For example, here is 70, but if we put here I don't know, maybe 100, it could be overtrained, and the result maybe is not the estimated, or okay. And finally we're gonna check the threshold with this algorithm, with this formula. It's only 4. Okay, then we're gonna graph it in our graph. And finally we're gonna train some new data with it's the same basis. And okay, we're gonna show the result here in the 4th graph. And something new here is that the user can write new data. For example, I don't know, if I want to know about I have the weight and the length of an animal, and I want to know if it's a rabbit or dog, I can also write it here in MATLAB, and I will know it. Okay, let's go to MATLAB. It's here, MATLAB, and this is our function. Okay, we're here in MATLAB, and we are gonna run the program. Okay, it's running, and then we can introduce the weight and the length of the animal. I don't know, maybe, and this is the graph. You can check it here. The greens are the green points are the rabbits, and the black points are the dogs. This is our training data classified with Adaboost model. And finally we will introduce the weight here. I don't know, maybe 3, and the weight also 3, and the length. And we can see now here, this is the new indicator for the animal. The color is black, and it implies that it's a dog. And well, we finish this part.
Now we will talk about the Haar-like features introductions. Haar-like features use a lot of positive images of faces in that case, and negative images without faces, to train the classifier. Then it extracts features from the image. Each feature is a single value obtained by subtracting sum of pixels under white rectangle from sum of pixels under black rectangle. So here you have these 3 examples. For example, the edge feature, the line feature, and 4 rectangle feature. But there were plenty of features, which means a lot of computation. To solve the problem, it was introduced the integral image concept. In MATLAB, we can obtain this image using this code. J equal integral image of E, where E is an image in grayscale. So we have an example of how it works, the integral image. It's only the sum of this value. For example, 1 plus 2 it's equal 3. Then 2 plus 2 plus 1 it's 5. It works in the same thing, or here on the rows. So 3 plus 1 it's 4. 2 plus 3 plus 1 is 6. So this code make this integral image. Then we have to select the best feature out of a lot of features using Adaboost. Applying every feature on all trained images and find for each feature the best threshold. So we select the feature with minimum error rate. This process will repeat over and over again with new weights until we have a good accuracy. Finally, we sum all these with classifiers. Even then, we will have a lot of features. That problem can be solved using the concept of cascade classifier. So we have this magic box. For example, we have a training set and the family of weak classifiers. So the output of this box is a single strong classifier using Adaboost. We will introduce the cascade of classifier concept. The cascade of classifier concept changes the idea of applying all of the features on a window. Instead, the cascade of classifier groups the feature into different stages and apply one by one. If a window fails, the first stage is discarded. So, however, if it passes, apply the second stage, and the process repeats again and again and again. The region which passes all the stages is a phase. So, for example, if we have an image, if we don't detect in the first stage a phase, this region of the image will be discarded. So, if all the stages passes, it means that we have here in that region a phase. So we can show example of that. Finally, we will show you a simple phase detection using Python plus the software non-fi plus the IDE file charm. We will use the OpenCV trainers, for example, Haar cascade, frontal phase, and Haar cascade eye, and a simple webcam. So this is the result of that. So we have to code the main function. When we obtain the video from the webcam, we define the OpenCV classifiers and start the webcam. So if we find an error, we can stop the program, and for example, when we can read the net frame, the program will be break. So this is on the instructions from the start the webcam. Then we have the process. So we have to convert the original image into grayscale and apply the phase classifier into the grayscale image. So we will draw the rectangle, and this color will be green. So once we detect the phase, we obtain a ROI, or region of interest. So we're looking for eyes inside this ROI. So we obtain the ROI. The eyes, we apply the eye classifier inside the ROI grayscale image. So we will use the cyan rectangle, and this cyan rectangle is that. So these two rectangles are drawn. So finally we show the image, the video, with the command imshow, and we put this title. In Spanish is Detector de rostro, and is face detecting in English. So finally we close all windows for save memory. So finally we have this code done. So I will run it. So the webcam is starting, and now it works. But it works at least on the face. And that's all.